Okay, good evening. Today we're going to be talking about film processing, and this is on chapter 9 in your dental radiography textbook. All right, so some of the objectives that we're going to be discussing are some key terms that are associated with processing of dental x-ray film. I'm going to go over how a latent image becomes a visual image. I'm going to talk about some advantages of automatic film processing, list and identify the component parts of the automatic film processor, and describe the mechanism of how the automatic film processor works. Also going to list and discuss the steps for automatic film processing, as well as how to take care of the automatic film processor and how to change the solutions and things like that. I'm going to talk about the 5 steps of the manual film processing and the 4 basic ingredients of the developer solution. Why are we going to be going over this? So the reason why is because we need to detail how film processing procedures work. Also need to be able to know what a darkroom is and what entails a darkroom. Also to discuss manual and automatic film processing, to be able to explain how the duplication process works, as well as discuss some common processing problems and how to fix them. So as a surprise as it may be, there are still offices out there that use traditional film. And as long as film is going to be used, we need to understand how film processing works. So steps that produce a visible image on a dental radiograph, what film processing is all about. So first it converts the latent image to a visible image, so something that you can see, and then it preserves the image so that it is permanent. So why is it necessary to know how to process the film manually if you have an automatic processor? Well, there are 2 reasons. So one, just in case you come across some type of film error, you need to be able to know how to fix it. And the way you know how to fix it is to identify what your problem is. And 2, to have the ability to develop film quickly. Like when you're working with endodontics, you're doing root canals, a lot of times you'll need that working x-ray. And a film can be developed manually in about 2 minutes. So as opposed to sometimes it takes 10 to 15 minutes on an automatic processor, sometimes knowing how to do it manually, it's quicker that way. If you have a dark room, of course. All right, some film processing fundamentals. So from the latent image to the visible image, and then talking about the visible image itself. So stored energy during exposure forms a pattern, and this is what creates an invisible image. That's what our latent image is, or latent image, excuse me. The chemical reaction then takes place when the latent image is submerged into a series of chemicals, which produces a visible image. Okay, then we have something called silver halide crystals. And silver halide crystals form a pattern and it creates an invisible image within the emulsion on the exposed film. So this is what absorbs the X-ray radiation during an X-ray exposure. The latent image is a pattern of stored energy on that exposed film. And this pattern cannot be seen, and it is referred to as a latent image. From latent image to visible image, a chemical reaction needs to happen. And this type of chemical reaction is known as a reduction reaction. And what we are reducing here are the halide portions of the exposed energized silver crystals. And that portion is removed. This gives you a sort of black metallic silver image. And this process has to take place under special darkroom conditions. So if you look over on page 83, and this is on figure 9-1, we'll see some pictures of what this silver halide crystals look like. So it starts with So it starts with some partial development and B. So you have your silver or your black halide, silver halide crystals on A. And then when you have areas that have partial development, that's what B looks like. And then C is when the development's completed. And then D is when the unexposed silver grains have been removed by fixing. And we'll talk about that shortly. All right, so selective reduction is when there is a reduction of energized exposed silver halide crystals that turn into black metallic silver. Unenergized, unexposed silver halide crystals are removed from the film, and the light image is made visible through this process. So the film is then first placed in a developer solution, and then it's rinsed with water, and then it's placed in a fixer solution, and then it's washed with water again. So sort of a simplified version of the processing procedures used that make a latent image visible. So the visible image is made of black, white, and gray areas, and they range from a radiolucent to a radiopaque image. Radiolucency is when you have an image that readily permits the passage, or let's say an object that readily permits passage of an X-ray beam. And when this happens, you get radiolucency. And this is what appears black. A radiopaque is when you have an object that resists the passage of the X-ray beam, and this appears white on an image. The black areas are created by deposits of black metallic silver, and the white areas result from removing the unexposed silver halide crystals. So automatic film processing is often preferred over manual film processing for a few reasons. One, because it takes less time. So earlier I said that it takes less time to do the manual processing. Well, that's because if you're doing a simplified version of it, but normally processing film in a dark room, there's a lot of equipment involved, a lot of stuff you have to get prepared. So the whole start to finish procedure is going to be longer than your automatic film processor. Also, time and temperature are automatically controlled in the automatic processor, so you don't have to worry about placing things like thermometers in there. Obviously, there's less equipment used and way less space is required. So a lot of dental offices that are still or that are using digital sensors still often keep their automatic processor just in case a computer goes out or one of the sensors breaks. That way there'll be some type of backup imaging available so your office doesn't kind of run to a halt. So an automatic film processor sort of automates all the film processing steps for you. So that's the good part. The bad part is that it limits the type of sizes of films that you can put in. And sometimes you have what's called a day loader. And a day loader is what we have in the lab. And this can be used in a room where there's white light. So there are automatic processors, big machines that are inside of dark rooms, and those actually require that they are inside of a dark room. The day loader, again, is what we have in our lab. So some of the requirements include some of the parts of the automatic processor, some step-by-step instructions, as well as how to take care of it. So when first turned on, most processors require a certain time before they're ready to process. This is because it's heating up all the chemicals to the specified temperature. And because of this, it's best to turn on the automatic processor the first thing in the morning when you enter the office, if your office is still using something like this. So some of the parts of the automatic processor include a roller transport system, and this is what moves the dental film through the developer, through the fixer, the water, and then through the drying components. This also there's also the processor housing. And the processor housing is what blocks the light and makes sort of like a sealed darkroom environment inside of the processor. It also has that film feed slot where we stick our films inside and it feeds it through the machine. The roller film transporter, and the developer compartment. So the film feed slot is for unwrapped films to be inserted into the automatic processor. The roller film transporter is a system of rollers that rapidly moves the film through the compartments. The developer and fixer compartments hold the solutions. The film is transported directly from the developer into the fixer without the rinsing step. Okay, then there's also something that's called a replenisher, and these are just pumps and small reservoirs of replenisher solutions. And we'll go over that in a second here. And then there's a film recovery slot. So the water compartment holds a circulating water, and the drying chamber holds heated air, and this is what dries the film. Let's go back here. So if you go back onto your book on page 85 on figure 9-4, there's sort of like a schematic of what our day processor looks like. Excuse me, this is what not a day processor. This is what a processor that looks like in the dark room. So you would stick your film through the slot, and it has first tank of developer. Then we have a fixer, and then a water compartment. So it's very, very similar to what we have now, except you feed the film through a slot, an external portion of the machine, rather than inside of that safe light compartment that you would normally unwrap your films in. So before processing, the exposed X-ray film and automatic processor must be present in the darkroom. So this is not talking about the daylight loader, but the actual big film processor. And the first thing that needs to be done is you have to prepare the darkroom. And this process must be done in safe light conditions. So you have to make sure that your darkroom is completely sealed from any light leaking through. You have to prepare your films for inserting them into the machine, and then that processes the films, and then you'll retrieve your films at the end. So we're going to talk about care and maintenance of the automatic processor and some of the processing solutions. So the automatic processor and the automatic processing solution must be carefully maintained to make sure that you have and are able to develop a diagnostic image. All right, so cleaning and replenishing schedule must be established as part of the preventative maintenance. And it usually requires daily or weekly cleaning, depending on how many films you're processing. Cleaning film is a type of film that you can feed through the processor that automatically cleans the rollers. Another thing that needs to be done is the levels have to be checked at the beginning of each day and replenished as necessary. If you don't add replenisher, you have a tank that's only partially filled. And so what happens is only part of the film gets submerged into the whatever chemical it is. And so what happens is you end up with exhausted solutions and what we call a non-diagnostic radiograph. All right, so for manual film processing, it's going to include the equipment, accessories, some step-by-step procedures, and as well as care and maintenance. So some of the steps include developing, rinsing, fixation, washing, and drying. So the step that takes the most time out of all of these is definitely the drying. All right, so to reduce the exposed energized silver halide crystals into the black metallic silver, a development solution needs to be used, and this softens the film emulsion. So remember, the emulsion is that layer of chemical that's on top of our film base, and this is where our latent image is stored. So when manually processing, like let's say for root canal procedures, the film is typically placed in the developer just long enough for an image to appear, so not the entire time. So this usually takes less than a minute. However, initial and final films should never be developed this way. So normally they should be submerged under the film for the specified amount of time, which is usually longer than a minute. So what rinsing does is it stops the development process. So this is necessary to remove the developer from the film and to stop the process. So when rinsing, you have unexposed crystals that still remain on the film. Therefore, rinsing needs to be done under a safe light because white light will expose those crystals and then distort your image. So fixing removes the unexposed, unenergized silver halide crystals from the film. And this also hardens the film emulsion so that no changes can be made to it. A working film for root canal procedures are placed in the fixer for about 1 minute and will last as long as the dentist needs to get the information he or she needs. So films that are not properly fixed will fade and turn brown in a short time. So this is one of the downfalls to rapidly developing your images or processing your images this way. So if you don't put it in the fixer for the required amount of time, the image will eventually just fade away. So washing removes all of the excess chemicals that you used from the emulsion. So once you get to this step, it no longer needs to be done under safe light conditions. So why would this be? Well, if you think about the unexposed crystals, they have been already removed. So there's nothing that's going to react with that white light. So therefore, you don't have to keep it under a safe light or keep it away from any white light. Once it's at the final washing stage, white light's not going to affect it. So film must be dried before they can be handled for mounting or viewing. Automatic processors use warm air to dry films more quickly. So there are different ways that film processor solutions can come. So sometimes we have a powder. So powder and concentrates require mixing, and this takes a lot of time, and a lot of practices are not going to take the time to do that. They also come in ready to use liquid, which is the most common way of getting your solution. And then there's also liquid concentrates. So this, in order to get the right concentration, you have to add distilled water in order for it to be a usable solution. So what would films look like if the developer solution was not diluted? Well, the film would appear overdeveloped. So if you have this liquid concentrate solution, getting that solution diluted just right is really important. So in order to maintain the freshness of your solutions, they should be replenished daily. Replenish just means filling it up to the top. And it should also be changed every month or every 3 to 4 weeks. And if you have an office that's high producing and you're constantly producing films, sometimes they'll need to be changed even more often than that. So in your developing agent, we have something called hydroquinone. These are the black tones and sharp contrasts. We also have Elon, which are the shades of gray. So both hydroquinone and Elon are chemicals that make up the developing agent. So hydroquinone is a certain chemical that's very temperature sensitive. So it's inactive below 60 degrees Fahrenheit and very active above 80 degrees Fahrenheit. So because of this chemical, this is the reason why we need to make sure that the processing solutions are kept at an optimal temperature. Nice thing about our day loader is it does that for us, so we don't have to worry about that. But just to let you know that that chemical is the reason why. The Elon is also known as metol, and this is what creates all the different shades of gray in our image. So both chemicals with black tones and sharp contrast, along with the shades of gray, is what we see in an X-ray. So the preservative that's used is a sodium sulfite, and we have sodium carbonate as an accelerator and potassium bromide as a restrainer. So the main purpose of the developer is to chemically reduce the exposed silver halide crystals to black metallic silver. The fixing agent has some chemicals known as sodium thiosulfate or ammonium thiosulfate, which is also called hypo. Uses a preservative called sodium sulfite and a hardening agent called potassium alum. And this is what actually makes or hardens up the emulsion so that it fixes the image. It also uses an acidifier, an acetic acid or sulfuric acid. And the purpose of the fixer solution is to remove all or clear out all the unexposed or underdeveloped silver halide crystals from your emulsion. All right, so now we're going to talk about some of the processing problems and some of the maintenance. So this will be, this includes identifying the parts of the processing tank, identifying the equipment, accessories needed to manually process film, list all the steps for manual film processing, and we'll talk about the care and maintenance of the processing solutions, the equipment, and equipment accessories used in manual film processing. We'll also talk about the primary function of the darkroom, as well as the location where it should be and how big it needs to be for your office. Also, safe lighting and what type of room lighting is required for that. And also all the miscellaneous requirements needed in the darkroom. Okay, so talking about film processing problems that can result from time and temperature errors, from chemical contamination errors, from film handling errors, and from lighting errors. So some of the equipment that you'll need is a processing tank or an automatic processor. So if manual film processing equipment includes a processing tank and a lot of different other accessory equipment. So in a manual film processing, you'll hand process each film. So you'll manually dunk it into different the different solutions. I don't think there's any offices that still do that, but we'll still go over it. And then we have a processing tank, which is divided into the processing tank itself that's divided into compartments that hold all your different solutions. Then you have two insert tanks, and this holds the developer and fixer solutions, and that fits, both of these fit into the master tank. And the master tank is suspended or suspends both insert tanks, and that's filled with like a circulating water. And then we have something called a mixing valve that controls the water temperature. So the developer is usually placed in the insert tank on the left, which is on the left, and then the fixer solution is on the right. An overflow is used to control the water level in the master tank, and the optimum temperature for the water bath is about 68 degrees Fahrenheit. Some of the accessories are a thermometer, a timer, some film hangers, and a stirring rod. The thermometer needs to be placed directly into the developer solution, and the temperature must always be checked before processing. Film hangers are necessary in order to dry the films, and stirring rod mixes the chemicals and equalizes the temperature of the solutions. So some step-by-step procedures include identifying the solutions, checking the solution levels, stirring the solutions, and then checking the temperature of the developer solutions. Also, the label, the film hanger, and we need to label that. You'll need to prepare the darkroom, unwrap the films, load the hanger, and set the timer. So all steps must be followed with correct infection control procedures, just as a reminder. So we'll need to immerse the films and activate the timer first. And once the timer goes off, then we remove all the films from the developer and rinse them. And then we want to rinse them to get all that developer off of it. And then we'll figure out what the fixing time is, immerse the films and activate the timer, and then remove the films from the fixer and place it into a water wash. So it doesn't hurt the films to stay in circulating water for a long period of time. So there's no really set period of time for the water wash. After that, we'll need to dry the films, remove the films from the rack, and then clean up. So we want to be careful not to scratch the films when clipping them on the film hanger. All right, some care and maintenance. So the processing solutions, the processing tank, and all the miscellaneous equipment. So we want to follow the manufacturer's instructions for storage, mixing, and use. So just be aware that the solutions deteriorate with exposure to air and then lots of use. And if you have chemical contamination, if you have developer that gets into your fixer, a fixer that gets into your developer, or too much water that gets into either, is what we talk about is what we mean when we're talking about chemical contamination. So exhausted processing solutions result in a non-diagnostic radiograph, and that radiograph will have to be replaced or retaken. So about your developer solution, so depleted from evaporation and removal of small amounts. So as time goes on, the developer solution will evaporate. And so this is one of the reasons why it kind of gets depleted. And then also when you dunk your film into it and then remove it, small amounts get removed. So it also adds to depleted solutions. So if exhausted developer does not fully develop, or if you don't replace your exhausted developer, you'll have a latent image that doesn't fully get developed. So fixer solution, same thing. It gets depleted from evaporation and also as well as removal of small amounts. And then if you dilute the fixer solution too much, like every time you rinse the developer from the film and place it into the fixer, small amounts of water get into the fixer, which dilutes the water each time it's transferred. And so if you don't replenish your exhausted fixer, it doesn't stop the chemical reaction sufficiently, and you end up with an overdeveloped film. So exhausted developer also reduces density and contrast. An exhausted fixer will cause the radiograph to turn a brown color and it'll transmit less light and lose their diagnostic quality. So this is why we have replenisher solutions inside of your processors, because both developer and fixer must be replenished. So replenisher solution is sort of the same thing as a developer and fixer, except that it's super concentrated. So it's designed to have to overcome some of the contamination that we talked about earlier, especially with water. A lot of the times you end up with solutions that are over diluted. And so this is why the replenisher is super concentrated to kind of overcome that. So oxidation is a process that occurs when developer and fixer combine with oxygen and then eventually lose their strength. So replenishment maintains adequate concentration of chemicals, and this makes sure basically that you have uniform results between solution changes. So the processing tank, so we have mineral salts in the water and carbonate in processing solutions that produce deposits on the inside walls and the insert tanks. So this is why the tanks have to be cleaned with the commercial cleaner or hydrochloric acid when the solutions are changed. So we want to make sure that we don't use any type of abrasive cleaners because this will interfere with the processing solutions. Some of the miscellaneous equipment include film hangers, stirring paddles, and plastic apron. The dark room itself is a completely darkened room or environment where the film can be handled and processed to produce your diagnostic images. So it must be designed such that there is no leakage of any light, and it has to have the right amount of equipment in it. So the room should be conveniently located near your X-ray room. This is because right after you seat your patient, you're going to go right into there and get to work. It should be the right size to fit all the equipment and all of the people that need to be in there. So usually just one or two people will need to be there at a time. And it's usually about the size of a small closet. It has to be equipped with the correct lighting, and it has to be arranged with ample workspace for all and adequate storage for all of your equipment. Also, the temperature and humidity should be controlled. Okay, like I said, it should be near where the X-ray units are and large enough to accommodate all the equipment and enough room to work. So the size of it is going to determine by how much film is processed on a daily basis and how many people are going to be in the room at any given time, how the type of processing equipment used, and the space required for the duplication process. So again, the lighting has to be light tight, no light leaks can be present. And a light leak is any white light that leaks into the dark room. So room lighting is required for procedures not associated with processing films. And safe lighting is a long type of wavelengths in the red-orange portion of the visible light spectrum. So safe lighting is basically a lamp with a low wattage bulb, so 15 watts or less, and it has a filter that removes all the short wavelengths that we don't want in that blue-green portion of the visible light spectrum, and we end up with that reddish-orange range of visible spectrum. So the safe light should be placed at least 4 feet away from the film that you're going to be processing. So some of the miscellaneous things that you'll need is some space, enough space to work. This will include enough counter areas. And then you should keep this area clean, dry, and free from processing chemicals. It should also be at the correct humidity level, and it should have the correct plumbing for darkroom conditions. So any unused portion of the developer is considered hazardous because of the high pH. So it's very basic. So we should never discharge used or unused developer in a septic system. I guess sewers are okay, but septic systems are, I guess, really sensitive to that. So the same thing with fixer. The solution should be run through a silver recovery unit to remove all the silver that's left in the fixer. Again, should never be discharged into a septic system. And then film should not be discarded with normal office trash. So they usually have some type of, I guess, recycling for that, just like the aluminum layer that goes in between the film. And then we have something called film duplication. So we'll go over the equipment that's needed and also the step-by-step procedures for this. So in a film duplication, we have an identical copy of an intraoral or extraoral film. It's made through a process called film duplication. So in order to duplicate films, you'll need a film duplicator and this is a commercially available light source and duplicating film. So the difference between duplicating film and standard intraoral film is, unlike intraoral film, duplicating film has a single emulsion layer and is never exposed to X-rays, only white light. So with film duplication, we'll want to arrange the original set of film, process film, in anatomic order. We'll place the duplicating film over the original film and secure this whole kind of configuration into a duplicator lid. So we'll set a timer and then we'll process the duplicating film and then label it. So the duplicating machine produces white light to expose the film. Because the film is light sensitive, the duplication process is performed in the darkroom under safe light. So we'll talk about the time and temperature. Sometimes we also have chemical contamination. We'll talk about some of the problems with film handling as well as lighting and some of the solutions for all of these. So some of the problems that we'll have with time and temperature are underdeveloped film, overdeveloped film, and something called reticulation of emulsion. So some of the things that can cause overdeveloped film is if you have a developer solution that is too concentrated, too warm, or film that is placed in the developer solution for too long. Some things that cause underdevelopment are something like an inaccurate timer, low developer temperature, inaccurate thermometer, a depleted or contamination developer solution, and then reticulation is caused by a sudden temperature change between solutions. So when you have chemical contamination, we'll end up with something called developer spots. Can have fixer spots as well, and then yellow-brown stains. So a neat work area can prevent errors like developer splash. Okay, some errors with film handling. We'll have a developer cutoff, a fixer cutoff, some overlap films, and air bubbles. So we'll need to handle the films by the edges until processing is complete. And then when you have developer cutoff, you'll notice a straight white border, and this represents the part of the film that results from insufficient developer levels. Fixer cutoff is the same thing. You'll have a straight black border. This represents the unfixed part of the film resulting from insufficient fixer levels. Another thing we can get is something called a fingernail artifact or a fingerprint artifact. And this happens when we are taking apart our films inside of that automatic processor. So this is why we want to make sure that we're not gripping them too tightly with our fingernails, or that we're not smudging the films before we put them in the inside of the developer. Okay, static electricity is caused by opening your films too quickly. So make sure you're opening them slowly, not too slowly, but ripping them apart can cause static electricity. And then we can get scratched film from also from mishandling them. Okay, if you have a light leak, your image will look black. And in the fogged film, you'll have an image that appears gray and lacks any image detail or contrast. And the way these errors can be prevented is to examine first your packets for little tiny tears or defects, and don't use these film packets that are torn or defective. Never unwrap your films in the presence of white light. So some of these are kind of obvious. All right. And if you have any questions, we can talk about them in class, or feel free to email me. All right. Thanks for listening.